Hello friends, welcome to engineering tutorial. So we'll continue our discussion with Thevenin Theorem application to circuits involving dependent sources. So this is the sixth question that we are going to discuss. So here we have a circuit which consists of a independent current source 1 ampere, two resistors 20 ohm, and a dependent source which is a current dependent voltage source. This is a voltage source, its value depends on this current flowing through the 20 ohm resistance. So we have to find the Thevenin equivalent circuit, that is VTH and RTH. So first let us find out VTH. So VTH is this open circuit voltage. Okay. So here the node voltage here will be VTH because there are nothing in between these 2 points. Also here in between these 2 points there is no resistor involved, so no voltage drop. So here also it will be VTH, the node voltage. Let us connect the ground here. Ground. This IV value is equal to VTH minus ground potential by 20 ohm, which is equal to VTH by 20. Most important thing. Now let us apply nodal analysis here at this node VTH. So the nodal equation will be this 1 ampere current is going towards the node, IV is going away from the node, and let us assume this current, it is flowing downwards. Whatever value it is flowing downwards. So 1 incoming current, 2 outgoing currents. So here the nodal equation will be 1 ampere is equal to IV plus VTH minus 20 IV, this is a voltage source, 20 IV divided by the resistance involved, which is 20. Okay, so now replace IV with this value in terms of VTH by 20. So if we replace it here, it will be VTH by 20, here it will be VTH by 20. 20 will get cancelled. This will be, I am writing for this equation only, it will be this part VTH minus VTH by 20, which is 0. So this term becomes 0. Okay, this term becomes 0. Now 1 is equal to VTH by 20, that implies VTH is equal to 20 volt. Thevenin voltage is equal to 20 volt. Okay, and IV is equal to VTH by 20, which is not required, but still let us calculate, which is 20 volt by 20, which is 1 ampere. It means this 1 ampere, it is flowing through this resistor 20 ohm entirely, and no current is flowing through this, which is proven here because VTH is only equal to 20 IV, which is 20 into 1 ampere, which is 20 volt. No voltage drop across this 20 ohm resistor. So VTH is entirely plus minus 20 IV, which is 20 volt. So VTH is calculated. Now let us calculate RTH. Okay. So we have calculated the VTH part. Now we will calculate the Thevenin resistance RTH. So for calculation of RTH, what we have to do, as there is an independent source present, we have to deactivate it. As it is a current source, we have to open circuit it and excite the circuit with another, let's say 1 ampere current source, as we have done in all the previous questions. Okay, and we have to find out the terminal voltage across this current source, 1 ampere current source. So you can also connect a 1 volt voltage source. So you do that and check whether the same result, the same answer is coming or not. I am connecting a 1 ampere current source. We have also done with 1 volt voltage source. We have seen both the methods. So 1 ampere current source we have connected, and this is the terminal voltage. So here, as there is no resistor involved, here the voltage will be V0. Here also in between these 2 points there are no resistor involved, so here also it is V0. So the nodal analysis will perform here to find V0, and RTH will be simply V0 by 1 ampere. Okay, so our objective is to find V0. Another important thing, this IV is equal to V0 by 20 ohm. This is the second important relationship. So assuming this is an outgoing current, the nodal analysis equation will be 1 incoming current 1 plus 2 outgoing currents, that is IV plus V0 minus 20 IV by 20 ohm. So we'll replace IV now. IV is V0 by 20, here V0 by 20, here also it will be V0 by 20. Get cancelled, so this will be V0 minus V0 by 20, which is entirely will become 0. So 1 is equal to V0 by 20. That implies V0 is equal to 20 volt. Okay, V0 is equal to 20 volt. Now RTH is equal to V0 by 1 ampere, which is 20 volt by 1 ampere, which is equal to 20 ohm. So RTH is equal to 20 ohm. VTH we calculated, it was coming 20 volt, I think VTH was 20 volt and RTH is coming as 20 ohm. Okay, VTH and RTH, both the parameters we calculated. So this is the 6th question related to application of Thevenin's theorem to circuits involving dependent sources. Okay.